This is the video for Mastery Study Guide Topic 21, Graphing and Solving a System of Two Linear Equations or Inequalities. For example number 1, we have equal signs, so we're graphing two lines and finding the intersection points. Let's start with this first line. 4 is the y-intercept, so we can plot 4 on the y-axis. 2/3 is the slope, rise 2, run 3. Plot a couple more points, and we can connect them with a line. Same thing for our second one. We have a y-intercept of -1 this time, so we're going to plot a point at -1, and then the slope is really down 1 over 1 because we have a -1 slope. So rise -1, run 1. Connect it with a line, and I can see that there is an intersection point at -3, 2. We can also solve this algebraically by setting them equal to each other. So we could do 2/3 x plus 4 is equal to -x minus 1. But actually graphing in this case is easier because then we don't have to worry about adding or subtracting with fractions. Our second example are inequalities. So we have to remember that we can have dotted or solid lines. So remember, dotted lines is greater than or less than, so both of these are going to be dotted, and then solid is greater than or equal to, less than or equal to. But again, this example only has dotted lines. So let's start with that first graph. It's in standard form. So this one we can actually graph by intercepts. So that graphing by intercepts, we make an intercept table. So I'm going to do this above, x, y. 0 for x, 0 for y. So if I plug in 0 for x, I get y is equal to 3. If I plug in 0 for y, I get x is equal to 3. So I can go ahead and plot both of those points and then connect them with a dotted line. I do have to remember to shade. So pick a point to shade. I always pick 0, 0, but it can't be on the line. So I'm gonna plot 0, 0 just to make sure I know what side it's on. When I plug it in, we get 0 plus 0 is greater than or equal to 3, which is not true. So I shaded the other side. So 0, 0 is not a solution because 0 is not greater than 3, so that's why I shaded above the line. Let's look at our next line. Again, we can graph this via intercept table. Plug in 0 for x, plug in 0 for y. When I plug in 0 for x, -y equals -4, so if I divide both sides by -1, I get y is equal to +4. Plugging in 0 for y, I get 2x equals -4. Divide both sides by 2, I get an x value of -2. You guys can also change these to slope-intercept form if you want. However, graphing in standard form via intercept table is not bad at all. So I can plot both of those points, 0, 4, -2, 0, connect them. Again, because of the symbol, we need a dotted line. And then I'll test 0, 0 once again for shading. So I get 0 is I get 2 times 0 minus 0, so that gives me 0 on the left is less than -4, which is not true. So I shade the other side, so the side that 0, 0 is not on. And then my solution is in the area where there's overlap, so I'm drawing that with the black marker right now. You can also denote that with an S and draw an arrow to it, but it's where the shading overlaps.